Let's begin with the new topic, gravitation. So the first question arises, why are we studying gravitation? We are studying gravitation because in building large aircrafts, buildings, or even small houses, we do encounter gravitational forces. If we don't take care of these forces, then all of these structures will fail. Hence, we need to have an overview of what gravitation is and what are its basics. So let's begin with gravitation. We all know that all planets move around the sun, and in the similar way, the moon revolves around the earth, and all other satellites do as well. In all these cases, there must be some kind of force that acts between these bodies that keep them in a certain path. Sir Isaac Newton formulated that actually the same force is responsible for all these motions. This force was called the gravitational force. Let's take an example which we had taken earlier. The stone moves in a circular path with a certain speed and changes its direction at every point in the experiment where we had tied a stone to a thread and we whirled it around in a circle holding the other end. The change in direction involves a change in velocity or acceleration. The force that causes this acceleration and keeps the body moving along the circular path is acting towards the center. This force is called the centripetal force, meaning the center-seeking force. The motion of moon around the earth is due to this centripetal force. The centripetal force is provided by the force of attraction of earth. If there were no such force, the moon would have simply moved in a straight line. Now let's take the famous example of apple falling towards earth. It is said that Newton was sitting beneath an apple tree when an apple fell on his head and he started thinking, why is this happening? That's quite an interesting story. Now, if we view this example from third law of motion, we should say that apple also attracts the earth. But if we apply the second law of motion, we will see that for a given force, acceleration is inversely proportional to the mass of an object. Now, as the mass of apple is small, very small, or we say negligibly small compared to that of earth, we see that earth does not move towards the apple. So all objects in the universe attract each other. This force of attraction between objects is called the gravitational force. Let's move on to the universal law of gravitation. It says that every object in the universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to the square of distance between them. The force is along the line joining the centers of the two objects. So if we say that this is object 1 and this is my object 2, so this is the center of object 2, this is center of object 1, and this is distance d, mass is m1, mass is m2, so force is directly proportional to m1 into m2. At the same time, this force is directly proportional to 1 upon d square. Now if we combine both of this, we get F is proportional to m1 m2 upon d square. Now to remove this proportionality sign, we introduce a constant which is called universal gravitational constant G m1 m2 upon d square. So this is the formula of force that acts between two bodies of mass m1 and mass m2 which have distance d between their centers, and this force acts along the line joining the two centers. Now the value of this G is 6.673 into 10 raised to the power of minus 11 Newton meter square upon kg square. So this is in SI units. Now, given the universal law of gravitation, this picture depicts how this force of gravitation will change as you change the parameters, that is mass m1, m2 and distance d. If we increase the mass, the force of gravity increases. Similarly, if the distance is increased, the force of gravity decreases. Now we move on to the next section, that is Kepler's laws of planetary motion. Kepler gave a set of 3 laws which were very important considering planetary motion. These laws were: the orbit of planet is an ellipse with sun at one of the foci. So in this picture, this is the sun here at one of the foci. The second law says that the line joining the planet and the sun sweep equal areas in equal intervals of time. This picture here shows that the satellite goes from point P1 to P2 in a time say t. The same satellite then goes from point P3 to P4 in the same time t. So according to this law, area 1 this is equal to area 2. The third law says that the cube of mean distance of planet from the sun is proportional to the square of its orbital period t. That is, a cube is proportional to t square, where a is the mean distance of planet from the sun. Now, the importance of universal law of gravitation. The universal law of gravitation successfully explained several phenomena which were believed to be unconnected. The first was the force that binds us to Earth, the motion of moon around the Earth, the motion of planets around the sun, and tides due to the moon and the sun. Let's now look into free fall. Whenever objects fall towards the Earth under the gravitational force alone, we say that the objects are in free fall. Free fall is an accelerated motion because of continuously increasing velocity towards the Earth. This acceleration in magnitude is equal to 9.8 meter per second square and is known as acceleration due to gravity. This picture here depicts a man under free fall due to Earth's gravitation if we neglect the air resistance. Now, how do we calculate the value of acceleration due to gravity? For this, we use universal law of gravitation. Let's say the force that acts between two bodies by universal law of gravitation is given by G m1 m2 upon r d square. Here, for calculation of value of acceleration due to gravity, we say m1 is the mass of object we are taking and m2 is the mass of Earth. Now, when we throw an object up into the sky, its distance from the Earth's center remains almost same as that of the radius of the Earth. We see it in a picture. Let's say this is our Earth, which is really huge. Its radius is, let's say, r. Now we throw an object up in the sky which is very small. Let's say this distance d. So here d plus r will be almost equal to r. We put this in this formula. So G m for small object, capital M for Earth's mass upon r plus d whole square, which is equal to G m upon r square. Now, the force acting due to gravity is given by mg, where g is the acceleration due to gravity and m is the mass of the object. So this is force acting on the object, which is also equal to this force. Therefore, we write mg equal to gm capital M upon r square. Small m gets cancelled and we get g equal to g capital M upon r square. Now when we plug in the values of g, mass of Earth and radius of Earth, we get the value of g to be 9.8 meters per second square. In order to remove the confusion that must be created here, the d that I've used here initially in the formula is not equal to the d that the object is thrown up in the sky. This d can be replaced by h, let's say, the height to which the object is thrown. So now we will say that h plus r is almost equal to capital R. Now when we talk about motion of objects under the influence of gravitational force of Earth, we refer to the three equations of motion we had earlier derived. I will write these three equations of motion again. The first one was v equal to u plus at. The second one was v square equal to u square plus 2as. And the third one was s equal to ut plus half at square. Now, in case of gravitational force due to Earth, this acceleration is replaced by the acceleration due to gravity, and the equations become v equal to u plus gt, v square equal to u square plus 2gs, and s equal to ut plus half gt square. The major confusion and the mistakes that are made in such problems which involves these equations is direction or the signs of acceleration and velocity. So whenever you try to solve a problem, choose a direction of positive. For me, I'll choose it to be the downward direction. So whenever my acceleration is in downward direction or my velocity is in downward direction, I will choose this to be my positive direction. We will stop here in this video. In the next video, we will learn about the gravitational force on Moon, and we will also learn about the concept of pressure. Thank you.